Consider the perspective of a student staring at a page of crossed lines, horizontal dashes, and numbers. To a beginner, a plus sign or a multiplication cross carries no inherent meaning. They are abstract symbols without tangible context. Teaching mathematics as a game of blind memorization, rather than a logical system, is the direct cause of innumeracy. Instead of symbols, this physical tile serves as a tangible translation device, helping to decode those difficult and abstract mathematical concepts. Relying on a physical object shifts the learner's focus. Instead of searching for a memorized answer, they observe the actual physics of math. Watching these objects interact shows the symmetry of basic arithmetic. Half of the operations are simply the physical reversal of the others. Start with several independent tiles scattered across a surface to establish a baseline of separated quantities. Pushing groups of objects together provides a physical definition of addition. This visual demonstration requires no abstract formulas to verify the total quantity. This leads to the concept of unaddition, which we use to describe traditional subtraction. Pulling those grouped items apart reverses the previous action. Subtraction is the act of undoing the grouping we just performed. Separating subtraction into its own memorization category creates an unnecessary cognitive load, as the operation is the act of reversing addition. We can now move from a single straight line into a broader two-dimensional workspace. Multiplication follows this same logic, serving as an escalation of physical grouping. Arranging tiles into a grid format shifts the math from counting a line to mapping a shape. In this framework, mathematical factors are the physical length and width of the grid. Multiplication is the calculation of the internal area bounded by those exterior dimensions. Division is often framed as a complex, long-form equation, but the tiles suggest a different approach. We call this unmultiplying. Division is the physical dismantling of the rectangle back into its foundational constraints. Visualizing division as unmultiplying removes the fear of the operation. It shows that scaled arithmetic is a perfectly reversible structural system. This physical manipulation aligns with the way humans naturally acquire fluency. Memorizing arithmetic rules is like attempting to learn a foreign language by only reading a dictionary. You lack the context for true understanding. The physical geometry of math acts as the underlying grammar for the language of numbers. Visual modeling grounds math in an intuitive, predictable architecture. Teaching concepts through simple physical realities makes maths hard to forget. We move away from training biological calculators to make innumeracy a thing of the past.